preparing for part B of the experiment. I'm going to look at different alcohols and their solubilities in water and hexanes. So let me line up some new test tubes and get them straight across. That was pretty good. And now I'm going to use my Sharpie and I'm going to use a reference from earlier, that water reference, and put a line at about 1 milliliter and about 2 milliliters. I've labeled all of the test tubes. This can be a little bit tedious, but it's well worth your time. I always want you to label everything. So I put, like, for example, on this one it says 1 hep for 1 heptanol. And then I'm gonna check its solubility in hexanes. And I have my initials, MFS, and the date, 1/3/21. So I did that for all of them. And now let's test. I'll start with the methanol test. So I'll fill up these 2 test tubes with approximately 1 milliliter of methanol. The first line, first graduation I drew on there, might be a little bit low. I'll do a little bit more. That's about a milliliter. Now for the next one, add approximately a milliliter. I need just a little bit more. Okay, that's about a milliliter of methanol. I've added to both. Next, I'll add the water and the hexanes. So this one I labeled as for water. So let's see what happens when I add the water. Pull it up closer. Ooh, I see some mixing lines there. That's a sign. See how it's kind of cloudy-ish? That's a sign it's dissolving. And yes, this is completely dissolved right away. Methanol is it's known. It's miscible in water. It'll dissolve in any proportion in water. So yep, as I thought, methanol and water, miscible. Now hexanes. So hexanes is on the opposite end of polarity. Water is very polar. Hexanes is very non-polar. Let's see what happens with hexanes and methanol. Oh, it's looking like 2 layers. Yeah, it does not look like they're dissolving well together. See the, as I tilt it, there's 2 distinct layers. Maybe it's the surface tension of the methanol. Let's shake it, give it a chance. No, it does not look like it wants to dissolve. Let's use the spatula though and really give it a chance. Swirl it a bit and see what happens. Oh, yep, it just separates out again. And let me get a close-up of that. As I swirl, you can see it gets cloudy-ish because the little beads of the different solvents are just like mixed in with each other, but they separate out into 2 clearly distinct layers. So hexanes, methanol, not miscible. There seems to be very little solubility between them. So hexanes is just 2 nonpolar for the polar methanol. Now for 1 butanol, I'll put approximately a milliliter of 1 butanol in both test tubes. See, butanol has a different scent to it. I smell it a little bit. It's a little stronger smelling than the methanol. Okay, put a little bit in there. And they're both at about a milliliter. Okay, cap my 1 butanol. And to my test tube labeled water, I'm going to add approximately a milliliter of water and see what happens. It's looking a little cloudy. It's looking like 2 layers, huh? Let's bring it closer. Get a good, yeah. Let's mix it though, see if we can get it. See if they're soluble in each other. It's looking like they're not gonna be soluble, doesn't it? Yeah, I think it's slow, but I think it's separating into 2 distinct layers. Yep. I believe water is more dense and it's on the bottom. Yeah, so they're close. They want it. Looks like they want to dissolve in each other, but now they're separating. Let's try the hexanes now. Put some hexanes in this 1-butanol. Hexanes, much more polar. We'll go on the opposite end of the polarity of solvents polarities. Okay, so far. Ooh, this looks. Oh, is that 2 layers? It's hard to say. I'm not sure actually. Let's give this one a mix. Let's get a good focus on it first. Oh, looks like it's miscible to me, or 50-50 dissolved at least. Yeah, that looks like 1 layer. So the 1-butanol is nonpolar enough to be soluble in hexanes, but it's not polar enough to be soluble in water. Maybe it dissolved a little bit because maybe some of the water dissolved in the butanol on top. Not sure, but yeah, so definitely soluble in hexanes, not in water. Now for 1-heptanol, this is some leftover heptanol. The label is not specific here. It should say 1-heptanol. This is leftover heptanol from the unknown NMR experiment, determining an unknown with NMR and IR. So I have my 1-heptanol water test tube. Let's see if we have enough for these two. Well, I think I will have just enough maybe. Okay, let's say we got about a milliliter there. I'm going to add to both first, so in case I run out, I might be a little low on both. Oh, this is looking pretty good. Just about enough. Okay, so I've got some 1-heptanol in my test tube where I'm going to test it against water, and also in my test tube I'm going to test it against hexane. I think you probably already know the answer to this, because we saw what happened with methanol, and then with 1-butanol, the 4-carbon alcohol. Now we've gotten to 7 carbons, made it even more nonpolar. So let's add the water. Oh, definitely 2 layers. Looks like 2 layers to me, huh? So let's give it a good mix. Give it a chance, though. Okay, we're definitely seeing some. Yeah, no, it's separated out much quicker than the 1-butanol. This 1-heptanol is more nonpolar, less soluble in water. Makes sense. So the 1-butanol was soluble in hexane. So let's see what happens with the heptanol. Hopefully it's obvious to you at this point. I'll get some of my hexanes, our very nonpolar hexanes. Add that. About a milliliter. How's it looking? Oh, it looks like one. Looks like it's dissolving slowly. Let's double check. Let's make sure. Let's give it a swirl. Saw some cloudiness as if it were, we're initially mixing. But yes, it is 1 layer. So it looks like 1-heptanol is very soluble in hexane. It's probably miscible. We know it's soluble at 50-50. As I was washing my test tube, I accidentally dropped it in the sink and it broke. It happens. But when this happens, don't put it in a waste container. That can cut the bags and then cut our janitors, clean it up for us. We want to do that. We want to put this in our glass waste container over here. In this glass waste container, then it's cardboard, so it won't cut through.